Today's goal is to write and solve work problems. This is the second of the most classic examples of applications of rational equations. Example 1. Henry takes 2 hours to wash 500 dishes. Kale takes 3 hours to wash 450 dishes. How long will they take working together to wash 1,000 dishes? This is about rate of tasks accomplished. So for these rate problems, the rate in which you're working is the number of tasks you've accomplished out of the amount of time. So for example, if I'm driving at 60 miles per hour, right, I'm going 60 miles, that would be my number of tasks in 1 hour, just as an example. Okay, so let's take a look at Henry's rate. It takes him 2 hours to wash 500 dishes. And Kale's rate, it takes her 3 hours, time goes in the denominator, to wash 450 dishes. And now it says working together. So if they're working together, we're combining or adding their rates together. And they together want to wash 1,000 dishes. And it asks, how long will it take to wash 1,000 dishes? That's the thing we don't know. So that's our variable x, right? We're saying that x is the amount of time, or we should say the number of hours it takes Henry and Kale to wash 1,000 dishes together. Okay, well here is our rational equation. We're just adding up their individual rate to get their rate working together. Now that we've written the equation, we're ready to solve it. To solve a rational equation, we need a least common denominator. We'll need a 2, a 3, and an x. So we can supplement with what we don't yet have in each denominator. So we have 500 over 2 plus 450 over 3. I'm just rewriting to give myself some space so that I can now add in. I need a 3 and x here. I need a 2 and the x here, and I need the 2 and the 3 here. Oops. You guys know how to solve from here. We have 1,500x over 6x plus 900x over 6x is 6,000x over 6x. Because the denominators are equal, the numerators must be equal. This happened to turn into, oops, I'm sorry, this is just 6,000, not 6,000x. This happened to turn into a linear equation, right? We've got x's but no x squares or anything like that. So linear equations, we get all the x's on one side, as they already are, and then divide by the coefficient. So x is 2.5. Now I'm not going to box this in because x is a variable that we came up with, right? You could have called it h for hours or t for together or whatever you wanted, right? X is our own doing. We just need to make sure we're answering the question. How long will it take to wash 1,000 dishes? Well, that's what we said x is. So our conclusion is it will take Kale and Henry 2.5 hours to wash 1,000 dishes together. This is our final conclusion. Okay, one more example today. Working by herself, Mia requires 16 minutes more than Aaliyah to solve a mathematics problem. Working together, they require 6 minutes. How long does it take Mia to do it by herself? This is the thing we don't know, the amount of time it takes Mia to solve if she works by herself. So let's call this x. That means that Mia's rate of homework completion, we're talking about her solving the problem, meaning one problem. So she can solve one problem in X amount of time. It looks like our unit is minutes, so we'll say X minutes and clarify this is a number of minutes. Okay, and then we're talking about Mia and Aaliyah. Working by herself, Mia requires 16 minutes more than Aaliyah. So Mia takes more time, so Aaliyah takes less time. In fact, Aaliyah takes 16 minutes less, so she can accomplish the task in x minus 16 minutes. To solve A, again meaning one math problem. And now we have information about them working together. If they're working together, they're combining or adding their rate. Working together, they can solve the problem, so one problem in 6 minutes. I like to write out the units to make sure, oh yeah, this was also a number of minutes. So this makes sense, we're just combining their rate to get the rate of them working together. Okay, here's my rational equation. To solve a rational equation, I need a least common denominator. I'll need an x, I'll need a 6, and I'll need an x minus 16. It's not the answer, it's just important, so I'm going to rewrite it. So I have 1 over x, again, just rewriting to give myself some room. So here I need a 6, and I need an x minus 16. Here I need a 6 and the x. Here I need the x and the x minus 16. Okay, let's multiply this out. If we're multiplying 6 times x minus 16 times 1, that just gives us 6 times x minus 16. Plus, here we're multiplying 1 times 6 times x. That gives us 6x. And again, multiplying by 1 makes this a little bit easier. Since my denominators are equal, my numerators must be equal. Maybe this is obvious to you what kind of equation you've turned it into. Maybe it's not obvious to you. If it's not obvious, let's go ahead and distribute a little bit so we can see what we're working with. Oh, we know these guys. This is a quadratic equation. Unlike a linear equation where you want x's on one side and the numbers on the other, if it's a quadratic equation, you need all the terms on one side. So let's combine like terms and then move everything over. I like to keep x squared positive, so let's leave that where it is. We'll move the other terms over. Now you have 0 equals x squared minus 28x plus 96. Well, quadratic equations are nice to solve if you can factor. If this isn't obvious to you, you'll have to use the quadratic formula, which is pretty time consuming. Might be worth trying, guess and check a little bit what number is multiplied to 96 and add up to negative 28. Well, 96 is even, so we could divide by 2. 96 divided by 2 gives you 48, but those won't add up to negative 28. So maybe you can divide by 4. But yeah, 4 times 24 gives you 96. Ooh, nice. If they're both negative, that'll add up to negative 28. But we don't want to box that in. This is a story problem, so we need to answer the question. How long does it take Mia to solve the problem if she works by herself? Well, does it take her 4 minutes or does it take her 28 minutes? Let's look back at our original equation. Aaliyah's rate is 1 over x minus 16 because it took her 16 minutes less than Mia to solve the problem. Now, if you're saying Mia's rate was 1 over 4 minutes, then Aaliyah's rate would be 1 over negative 12. Well, you can't finish a problem in negative 12 minutes. That doesn't make sense. If we said Mia's rate was 1 over 24, meaning it took her 24 minutes to solve the problem, well, 24 minus 16, that means it would take Aaliyah only 8 minutes to solve the problem on her own. That makes more sense. So 4 is a solution to this rational equation, but it's not a solution to the story problem because it doesn't allow for all of the facts to make sense. So this must be our answer here, meaning it takes, this was about Mia. It takes Mia this number of minutes, so 28 minutes, to solve a math problem if she works by herself.